This video is to show you how to do goal 4 and 5 from the energy unit. If we look at the roller coaster that moves between A, B, C, and D, and E, what we want to do is we want to use the conservation of energy to know what the energy is at each position. So at the top, we can assume, they tell us here, that there's zero kinetic energy because it's at rest. So if we look at that equation, we're able to conclude that, hey, that speed must be zero because there's obviously some mass to the car. That speed must be zero because there's zero kinetic energy at the top. So the car is at the top at rest, and they're telling us it has 400,000 joules of potential energy. So according to this equation, total energy is KE plus PE. It's really the sum of all the energies in the system. So just add them up. 4,000 plus 0 gives us a total energy of 4,000 joules. So the units will be joules every time for energy. So the next thing you should be able to conclude is, hey, if I know the total energy at the top, then according to the conservation of energy, that total energy will not change at any location. So we can conclude that if we're only considering these two kinds of energy, we're not thinking about heat loss. We're just going to say, hey, total energy, every single position, A, B, C, D, and E, is always the same, and it's going to be 4,000. Then that makes it fairly easy to work backwards and say, hey, if I know total energy is kinetic or potential plus kinetic, then for, say, position C, I know my total energy is 4,000. My potential is 1,500. So all I have to do is to subtract 1,500 from both sides of my equation here, and that will tell me how much kinetic I have. So if I do that with my calculator, 4,000 minus 1,500, I end up with 2,500 joules of energy being kinetic. If I use that same reasoning, I just have to take 4,000 minus 3,000, and I get 1,000, because these two together have to add up to be my total. So that leaves me with two places, B and D, where I don't have any information. So I have to go to my drawing and think about it. If at B, I'm at the bottom of my hill, one of the other things you can conclude from these problems is that the height at the bottom of the hill is considered to be 0. So if I look at my potential energy equation, I can actually figure out what that is from that one fact. Because if there's no height, 0 height, then everything here multiplied by 0 is going to give me 0 potential energy. So at position B and D, I can conclude that my potential energy is 0 here and here. So therefore, that means all of the energy has been changed to kinetic, and that must mean the kinetic energy at each location is 4,000. Now, goal 6 on the next page is actually similar, but they've added one step. They're going to ask you to fill out kinetic, potential, and total in exactly the same way we just did, but then they're going to add another step. From that, can you figure out height and velocity? So my advice on this problem is to do this exactly like we did the last problem. So 50,000 joules of potential, kinetic is 0, so we're going to add them up because remember, total energy is just add up the two kinds of energy, potential plus kinetic. Once you know the total energy here, you know it everywhere because of the conservation of energy. The energy is 50,000 at the top, at the bottom, halfway up, everywhere. Once we know that, we can work backwards to figure out the kinetic energy if we're given the potential. So if 50,000 is the total, 20,000 at the point top of C is, we must have 30,000 because add these two together, 2 plus 3 is 5, and then all those zeros, okay? This one, 40,000 is at the top of E as potential, so there must be 10,000 of kinetic, because these two have to add up to this one. So then you might wonder, how the heck am I going to find height or velocity? Well, this is where you always go to the equation. If we look at the equation for potential energy, it's m times g times h. And if they're giving you potential, right here. You need to know the mass. And sure enough, if you look at the top of the problem, they do tell us the mass is 500 kilograms. We also know G is always 10, so we know everything except for H, so we can solve for it. So we're going to make our potential energy, our first example would be 50,000, equals our M, which is 500, times G, which is 10, and then solve for H. So if I simplify, 50,000 equals 5 with 1, 2, 3 zeros. H, I'm going to have to divide both sides by 5,000. And the quick way to do that is I know I can cancel out 3 zeros here and 3 zeros here. So 50 divided by 5 is going to be 10, is going to be my height. So I know my height is 10 meters. All right, how about over here? How do I find velocity? KE is 1/2 mv squared. So if I have 0 kinetic energy, which I do, 1/2, I know my mass is 500. What does my V have to be to come up with 0 as an answer? It has to be 0 also. So we're going to say our velocity is 0. All right, how about this problem right here? 20,000 joules. If I know my potential energy is 20,000 joules here, then I'm going to do the same problem. I'm going to say M times G times H. So 500 is my M, G is 10, and solve for H. So I basically have the same exact problem multiple times. So 20,000 divided by 5,000 is what I'll have to do. So that turns out to be, cancel 3 zeros, 20 divided by 5 is 4. So my height will be 4. The last problem is the same way. I'm going to go back to the other heights. So the last problem would be 40,000 equals M times G times H. So same exact thing, take 40,000 and divide it by 5,000 to get H. So 3 zeros, 40 divided by 5 is 8. So my height would be 8 meters here. All right, so how do I figure out the potential energy at positions B and D? So I have to go back and look at my picture and realize, oh yeah, there's no height here because it's at the bottom of the hill. So I'm going to put 0 height here, 0 height here, and just like I realized if I had 0 velocity, if I have 0 height, that means I must have 0 potential energy because M and G are going to have values. This is the only way that I could end up being correct, as I'd have to have 0 potential energy. So what does that tell me about the kinetic energy? I know that all 50,000 joules, if none of them are potential, all of them have to be kinetic. So I'm going to put 50,000 in for both of these, and then go ahead and solve for my velocities for these scenarios. B and D will be the same, but I'll have to do the same problem, same reasoning that I did over here, just using the kinetic energy equation. So let's try this one. If we know the kinetic energy is 50,000, right? I got to plug it in for KE. I know 1/2 is part of the equation. M is 500 times V squared. So I'm going to have to do this math problem. Simplifying, 500,000 equals 250 times V squared. So I'm going to have to, this is going to be 250 every time. I'm going to divide both sides by 250. So if I take 50,000 divided by 250, I get 200 equaling V squared. So then I've got to take the square root of both sides. So square root, second function button gets me there, and I can enter 200. I get, this one hasn't been changed over, this calculator, so I'm going to go into my mode, and I'm going to go down, so I can go to enter classic, because that's going to help me get rid of my radicals when I'm done. So let me try that again. Second function, square root, enter 200, and I should hopefully get my answer of 14.14. So I'll say V equals 14 if I just want to round it off. So the speed would be 14 meters per second. And that would give me the same answer because in both cases for B and D, I have the same kinetic energy, so it'll be 14. So for both the other two, I'm going to have to do two similar problems. I'm just going to use 30,000 and 10,000 as my problem. So 30,000 equals 1/2 times 500, just going to make it 250 V squared. So 30,000 divided by 250, second function square root, second function answer. Whoops, I think I did that wrong. Yeah, I did. I clicked on the wrong thing. So let me try that again. 30,000 divided by 250 is 120, second function square root, there it is. And then put in your answer. I got 10.95, which rounds off to be 11. So the speed at 4 would be 11 meters per second. And finally, the last one is what's the speed at position E? And that has 10,000 joules of kinetic energy. So that's going to be 250 times V squared. So on my calculator, it would be 10,000, divided by 250 equals 40, second function square root, second function answer gives me 6.3. V equals 6.3 meters per second. And that's how I do goal 4 and 5.